All right, hello everyone, this is Mr. Crozier. I'm going to do some examples for you from 3-4, which is about exponential and logarithmic equations. And the key to this assignment is you are just going to be switching back and forth between exponents and logs. If you're in logs, you're going to switch to exponents. If you're in exponents, you're going to switch to logs. All right, so here we go. Letter A. We have this long problem here, and our job is to figure out what this x is. We're going to draw a line down the middle. And we're going to do stuff to both sides so we can get to this x. Well, first off, I can just subtract this 1 over, so let me just go ahead and do that right now. Subtract that 1 over, and that's now 6. And now to undo this fraction, we're just going to multiply by 3/2, and the fraction's gone. And so now I have 5 to the x is equal to 18 divided by 2 is 9. So there's my first step. I got rid of the 1. And I got rid of the fraction. So now I can see where I'm at, right? I'm at 5 to some power makes 9. 5 to the, let me just a little logic here. 5 to the first power is 1. 5 to the second power is 25. So I know what my answer is. My answer is 1 point something. I just have to figure out what those decimals are. All right, and the way we do that is we take the log of both sides. So I'm going to rewrite this as log 5x equals log 9. Now what base do I want to use? A couple different options here, but if we use the base of 5, it makes this real easy to that can go away to just 1, and I'm left with x is equal to log 5, 9. And now I have my calculator, and there's two ways to get to that, right? We could do log of 9 divided by log of 5. Or if you know the button on your calculator, it's Math A, log 5 of 9, and there's that answer. So my answer is 1.365. Now we should check that. So I'm going to store this, press the store button. Store button's down here. Store it into x. So every time I hit x, that number comes out. And I'm going to just type this in right here. 2 times 5 raised to the x power. That divided by 3 plus 1, and it's going to give me 7 like it's supposed to right there. So that checks out. So let's take advantage of your calculator, store it, check it. All right, problem number, or letter B. Again, where are we at here? We're at an exponent problem that we're going to make a log problem so it's easier to solve. Let me do 2 steps. Let's see here. Let's subtract this 5 over, that's 8, divided 2 over, that's 4. E to some power is 8. And again, let's do some estimating here. E is about 2.71. 2.71 to the first power would be 2.71. 2.71 to the second power, let's see what that is. 2.71 squared. Whoops, I forgot to divide this by 2 here. This needs to be a 4. 2.71 to the second power is 7.3. So now we know that if I want to get e to some power to make 4, because I divided this by 2, it's going to be somewhere between 1 and 2 again. So again, I'm at this point where it's 1 point something. Let's check the math again. I divided or subtracted the 5 over, divided the 2 over. I have a 4 there. And by this estimation, I know where my answer is. My answer falls somewhere between 1 and 2. All right, how do we solve this? Well, we're going to do the same logic we did up here. We're going to take the log of both sides. Log of e to the x of log of 4. And again, I have my choice of base. And I'm going to choose the base e. And the base e, what it does is it knocks this away. So this is x. And log base e is just the natural log of 4. Your calculator has a button for this one. So the button for that one is just right down here. I can just type in natural log of 4. And your calculator knows that it's an e. So we do that. And there we go, 1.386. Again, let's store that into x. I've stored that into x, and let's check this math. 2 e to the x plus 5 is 13. All right, let's do a couple more problems. Problem C. This problem is a log problem that I'm going to find the answer to by making it an exponent problem. All right, step number 1. Let's see here. Let's subtract this away. So that's 3. So I have log base 2 of x plus 1 is not 3, it's 2. I subtracted that over, and now let's just go ahead and change it to a power problem. Whoops, this should have been 3, I'm sorry. 6 minus 3 is 3. Going too fast here. Let's slow down and let's go ahead and check this. Let's see here. If I take this and make this into a exponent problem, I have 2 to the third equals x plus 1. So I've went from the world of logs to the world of exponents. This is 8, and this is x plus 1, so subtract that over is 7. This is an easy one to check. We can check this by just plugging this in right here. Let's do the check without the calculator this time. 3 plus log base 2 x plus 1. 7 plus 1 is 8. So that's 3 plus, we don't even need a calculator for that. That's 3. And yeah, 3 plus 3 is 6. So you can always go through and check them. If they're easy, check them without a calculator. All right, problem D. Again, we have a log problem. How are we going to solve it? Well, we're going to make it an exponent problem. Subtract the 1 over, so I have ln of 5x. Anytime I see this, I always like to put parentheses around it just so I don't forget that these two are together. All right, again, what do we need to do? Well, we need to put the base in there. That's an e. I really could rewrite it. I mean, if you can rewrite it just like that. It means the exact same thing. E to the 12th. E to the 12th is equal to 5x. And now I divide by x, or by 5. So I have e to the 12th divided by 5. And that's a good answer. Let's see what that is as a decimal. Let's see here. E to the 12th power divided by 5 is 32,000. So if we wanted to estimate it, we could say 32,550.958. Let's go ahead and check that. Don't want to check this without a calculator. Store, hit store, store it into x. And let's see here. ln of 5x plus 1, and it does equal 13. So the great thing about these problems, every time you do a problem, you can use the calculator and check it, or you can check it by hand. All right, again, the idea of this lesson is if you have an exponent problem, turn it into a log problem. If you have a log problem, turn it into an exponent problem, and then you'll be able to get to the answer.